Welcome to Facing on the Lathe with yours truly, John Waddick, along with Master Toolmaker Don Howard. In this video, we're going to cover a few things. Number one, how to touch off the end of a part on the lathe. Two, how to make a light pass and to use that to check whether you're at the proper tool height. How to zero the digital readout, also known as the DRO. How to do a cleanup cut and to re-zero the DRO. Then we'll review how to use the power crossfeed lever. And finally, we will finish up with a safety review of facing operations. So let's get right into this video with touching off the end. So here we go with Don Howard.
Next step is we'll touch off the end of our part and get ready to face it off and verify our tool height.
Okay, so Jason, you're going to want to move over to that side. Now Don is, he's doing a crank here. He's bringing the tool to the end, and he's just touching it. So that's called touching off. And now he's using the, is it called the cross slide?
Yes, I'm using a cross-slide hand crank to move my cross slide back and forth across the end of the part in order to face it off.
Okay. So this operation of like smoothing off the end is known as facing. Now, Don, we need to check to make sure that our cutting head is at the center. How does it feel to you?
It feels good.
Wow.
We set up the center line pretty well.
All right, so if we did not set it up properly, and of course Don, being a master tool maker, does things right, but if for you in the center you got a bump coming out, okay? If it's just like a cylindrical piece coming out, that means that your tool was
Too low.
too low. Okay, that's too low. And if it was a cone shape?
It means your tool is too high.
Now you may forget that, but just remember, if there's some kind of protrusion at the center, you're not at the right height, and you need to adjust that using, remember, the idea of the vertical scale. Now, Don, one of the things is, remember, we're never going to touch anything in here while it's turning.
Correct.
And we have to be very careful about touching machine parts. Okay, one of the things that you'll want to probably do is look at a shiny surface. Okay, and I mean we're all attracted to shiny things, and you'll want to rub your hand on.
There's a penny.
Yeah, you want to rub your hand on there. Now, there are times when maybe you just want to feel to see if there is that nub in there. You can do that carefully, but it's usually better to use your rule and just move it back and forth, and if you don't feel a bump. On the edge of any machine part are going to be sharp edges or even burrs that come off that could give you terrible slivers or cuts. So you don't want to be running your hand along the edge of a machine part. Is that usually the case?
That's a very good case, and do not do that.
And usually when these parts come out of the machine, they would be filed down to take off those sharp edges.
Correct.
Okay. All right, so Don, we have touched off.
Let's review what was covered on touching off the end. First off, you want to use the hand crank to move the carriage longitudinally. That means in the X direction, or in other words, toward the part or toward the headstock. You're going to do this until the tool touches the part and you start seeing some chips being formed. You only want to go in maybe about 5/1000ths of an inch. This is just a very light touch. Then you're going to use the crossfeed knob to make a light pass across the part. That would be the cross direction or the Y direction, which is perpendicular to the axis of rotation. You then turn off the machine so that we can then check to make sure that the tool was indeed at the correct height. You then check to see if there's anything protruding from the center of the part. If there's a cylinder at the center, that means your tool is too low and we're going to have to raise it. Likewise, if there's a cone at the center, the tool is too high. If there's some kind of shape at the center, you can't tell what it is, just know that you do have to change the height of your tool. And remember the way we do that. You use a ruler, you hold your steel rule, the 6-inch steel rule, against your part with the tool, with the tip of the tool. If your ruler is perfectly vertical, then you're at the correct height. If your ruler is inclined one way or another, you have to adjust the height of the carriage, not actually the carriage, you're not going to be able to do that. You have to change the height of the tool in the tool holder so that your ruler is perfectly vertical. Then once you have that done, you probably want to go back and take another light pass to just ensure that you don't get a protrusion at the center. Let's go on and talk about how to zero the digital readout, also known as the DRO.
All right. Is there something next we need to do?
Well, we can zero our machine. We can zero that axis so that we know the relationship of the tool in relationship to the part.
All right. Now, I see over here X and Y. All right. So you're going to probably do something and... All right. So go ahead and just tell me what you're doing. I'll shut the heck up.
All right. What I'm going to do is I'm facing off the material to make sure it's 0 and that it's cleaned up all the way across, and I can set a 0 here on my digital readout.
Okay, so Don's turning the machine on. He touches it. So now you just moved it closer to the part?
Yes, I did.
All right, by about 10 thousandths, and then he hit the X0 button? Okay, this is X, right?
Yes.
This is X, so that was set at 0. Now he's going to engage, no, he's not going to, he's engaging the power feed. All right, and we're going to need to go over how that is. Don's putting some coolant on there. I believe that's coolant. It says Cool Tool.
Yes. It's Cool Tool. It's a lubrication and a cooling agent, basically. If I can keep the tool cool, it'll help reduce heat, which basically would help melt material. We don't want to be melting our material. We want the material to touch and also preserve tool life.
All right, so you're going to turn this off for a second. I'm just going to talk about some. Now, you saw as that was happening, there was a chip in there. Okay, now, once again, very shiny. I'm sorry, I dropped it. Don't go in there while something is moving and put your hand in there to grab anything. If you need to do anything near there, you would use the brush, okay? All right, so now you've faced that off, Don. That position where the tool is right now is, why is it not at 0?
Because I backed it off the face so I didn't kind of get back.
Okay, so when he brought it out, he brought it in the, that's the positive X direction away, so we're not touching. But if we need to know where the end is, he can crank that in, and as soon as he gets to 0, we are right where the end of the part is now. Okay? All right, so we've zeroed our X. So Don, in a sense, going toward is negative and going away is positive.
Correct.
And it's kind of like a graph.
Let's review how to zero that DRO and then the cleanup operation that Don did. So after the light pass was taken, and that was used to check to make sure the height was at the tool height was at the correct vertical position. After you do that, you can hit X0, and that'll zero it in the X direction. The X direction, remember, is the longitudinal one that's parallel to the axis of rotation. And that newly machined end is now going to be 0. We then brought the cutter about 15 thousandths of an inch toward the part. We moved the cutting tool away from the parts. You don't ever want to try to move a cutter when the spindle isn't turning into it. That's not a good idea. So we were on the cutting tool was on the side of the part. Don moved in, and when you move toward the part, that is the negative X direction. He moved in about 15 thousandths and made what's known as a cleanup cut. And like I said, the X direction is also known as the longitudinal direction. All right, once he moved into that new position, he wanted to cut off that 15 thousandths that he just moved. And he engaged the power crossfeed, which we're going to review in the next slide. He then, after he did that cleanup pass of the 15 thousandths, he hit the X0 again on the DRO. and this set the DRO to 0. So the new end location of the part was now re-zeroed. While he was making that cut, Don used a coolant oil to reduce heat and friction. And when any chips form while you're machining, you never want to put your hand in there and grab them. If you need to remove them, you use the chip brush, and that was demonstrated. Now, what the cleanup cut provides you with is a few things. Number one, it's a perfectly flat end surface. When you just cut off a piece of stock with a bandsaw or take it off the rack, the end may not be flat or perpendicular to the axis of rotation. So the cleanup cut provides that flat surface that is also perfectly perpendicular to the rotational axis of the part. So you have a perfectly true surface after doing this cleanup cut. And now with this 0, this new surface is now your 0. We're now going to talk about how to use the power crossfeed. It was demonstrated quickly in the previous video segment, but we're going to review it again here.
That was a facing operation. Now, one of the things I want to just review with the facing operation is what you did with this lever, because Jason was on the other side. Okay, is this lever got anything to do with anything we need?
No, the engineering student will not need to know what that lever is.
All right,
This is a half nut lever used for threading.
Okay, don't touch this. Okay, touch this, you're going to get your hand slapped. All right, Don, this is a lever. Is it all right if I turn it?
You can touch it.
Okay, now it looks like I can go down,
Right.
and I can go up. But before I can move it, I have to like push it in,
Right.
and then up
Yes.
or down.
Yep.
All right, tell me, what is this?
This is your feed and gauge lever, all right? In order to make this thing go under power, machine a part under power, I have to move this feed and gauge lever, all right? With the spindle running, I can pull this lever out, and I can pull it down, and now you can see that the cross feed handle is going on its own. It's an automatic feed.
So now this cutting tool is moving into the part.
Correct.
So instead of Don having to do the hand crank, this, could you repeat that? In and down?
In and down, out and down,
Out and down.
right?
That moves the cutter inward. Okay, so now you stop that. What if I want to move out?
If I want to move out, in other words, move this cutter from the center of the part outward, I have to do a feed reverse. So I have to shut my spindle off, and I have to change this lever that's on my headstock. Shut my spindle off, I rotate this the other direction, I turn my spindle back on, and now you can see that I'm feeding out. The direction of my cross feed handle has changed.
It's going in the opposite direction. All right, now people usually do, can I turn this off?
Yes.
Now, do machinists usually power feed out, or do they just crank out?
That's individual, up to the individual and what type of finish you're trying to get.
Okay. All right, so push in and go down does the cross feed. You're either going to be forward, which is going to move it in, and you have to turn that, or reverse if you want to move it out. Now, if you're a novice like I would probably just always keep it on forward, and I would hand crank away. But, hey, that's just me. You do what your instructor thinks is best.
Let's take a look at what Don mentioned in the last video segment about the power crossfeed. For it to be engaged and working, the spindle has to be on. You're not going to get power crossfeed with the spindle off. Now with the power feed engage lever, to engage it, you pull it out and then push it down to engage crossfeed. If you pulled it out or pushed it out and then pushed it up, it would engage the longitudinal feed. So in this case with facing, we want to engage the cross feed, so we go down with this lever. When you're done with the power feed, you return that power feed engage lever to the neutral position, and it'll stop the power cross feed. Now what that crossfeed does is essentially turns the crossfeed lever for you so you don't have to. And you saw in the previous video clip that when it was engaged, the circular hand crank on the crossfeed was actually turning on its own. To reverse the direction of the power crossfeed, you have to first turn off the spindle because you're not going to want to try to go from forward to reverse with the spindle on. That's like going in your car and going in drive and then trying while the car is in motion to put it in reverse. Don't ever try that in your car, and don't ever do that same operation on the lathe. All right, then you have to set your feed direction lever to reverse on the headstock, and then Don said you don't want to use the half nut lever next to the E-stop. So let's take a look at some pictures of what we're talking about here. Oh, and there is the symbol we're going to look for on the headstock. All right, so on the headstock there is the feed reverse lever, and when you change it from the forward position, which is in right now, to the reverse, which would be toward the left, the machine has to be off, and after you engage that knob, you want to turn the spindle to make sure that the gearing has been properly engaged. On the next slide, just a few things. We have the power feed lever you see labeled there. Remember, that's something you push in and then push down to do the cross feed. Don mentioned this thing called the half nut lever. That's something we're not going to touch. That's for threading purposes. Just leave it where it is. If you're not sure if it's in the right position, ask your instructor. And then just to point out always, the emergency stop. You should always know where that is. If something goes terribly wrong, you just push that in. It'll stop the power to the machine. We're now ready to do some safety review. All right, remember, you never want to touch anything that's moving. You don't want to touch the spindle. You don't want to touch any chips. You don't want to touch the part. When that machine is operating, you're to stay clear of the spindle area of the part, the tooling, and the feed screw. Remember, machine parts can have very razor sharp edges. If you're an ice skater or hockey player, you know that one of the ways that a blade gets sharpened is by machining it with a stone. When you machine a surface, it creates very, very sharp edges. You're not to run your hands on a sharp edged part. Usually before you touch edges of parts, you would lightly file them down, usually once they're out of the machine. If chips form, don't go in there grabbing them. Most of the time they're okay the way they are, but if they do become a nuisance, you use a chip brush only. You never use your hand. You never put your hand near the moving spindle part or tool. Remember, know where the emergency stop is in case something does go drastically wrong. You don't have to fumble with the on-off switch. You can just push that red button in and the machine's power will be terminated. Remember, avoid all kinds of apparel that can get you pulled into the lathe. Any drawstrings on clothing or hooding, neckties, necklaces, long sleeves, long hair. These are all things that can be deadly near a lathe. So make sure that anything that you're wearing is not going to dangle, is not going to be in a position where it can be caught into any of the rotating parts and pull you into that lathe. Let's review with 5 questions that you will hopefully answer correctly and pass in to your lab instructor. Number 1, how can you determine if the cutting tool is properly centered on the part after a cleanup pass has been made? 2, what direction is the carriage moving when the value of X changes on the DRO? And then follow that up with the question, how is X zeroed on the DRO? 3, why is a cleanup cut performed at the start of a facing operation? 4, describe how to engage the power crossfeed in the forward direction. How can the crossfeed be reversed? In fact, the crossfeed direction. And number 5, list the 5 facing safety rules that were reviewed in this video. I'll see you next time when we do something known as turning. Until then, see you later.